Hello, we are here for one more lesson of this T-FLEX analysis training course, and today we are going to talk about dynamic studies. This is another group. We've been talking about other types of analysis, so the dynamic analysis module of T-FLEX is used to calculate these phenomena that are characterized by change in time stress state of these models, parts, whatever you want to study. To work with these types of studies, we don't need separate additional constructions, and we can use, as you've seen already for the previous types, we can use the models and what is done inside T-FLEX CAD. Inside this dynamic analysis, it is considered under the action of time varying external influences of forces, pressures, accelerations applied to the system. So we can have multiple examples, for example, a shaft rotating, a vehicle passing over a bridge, seismic vibrations, filling of a hopper with sand, whatever. So there are millions of applications for this kind of studies. A stress state of the mechanical system will also change in time, and the analysis of this type of situations, it is important in many practical cases as dynamic stresses and inertial forces, which can influence the overall performance of the mechanical system that we are studying. Another important factor it is that as a result of this dynamic study, we get the same type of calculation results as for the static analysis. So we are talking about displacements, stresses, factor of safety. But each result presented, it is connected to a time perspective. So it corresponds to a time interval and a specific time step interval. So we will see a couple of examples about this. From the mathematical point of view, there are two main approaches to solve this type of systems. And they are called first mode superposition and transitional process. So this series, they have differences, and when we create a new study, as you can see here, we have, opening the type of study, we have this mode dynamic analysis, so mode superposition, mode transitional process. This is, or these are mathematical equations in terms of what it is done. If you want to develop a little what each one of these methods does, you can read a little about inside our theoretical course. But doing a little simplification of a difference that you can notice. So in the mode superposition, we have a couple of n-related differential equations of motion. They are transformed in the equivalent system consisting of independent ordinary differential equations. So we have thousands or even millions of equations that going through this transformation. And the resulting solution of the system is presented as a sum of the oscillation forms. The advantage of this method it is that the computational efficiency is solved using reduced equations, and it's faster, as you may guess. We have a restriction also in this superposition method, which is the impossibility to use nonlinear studies. On the other hand, the accuracy of the method depends in several factors. So we can increase in accuracy, but the result will take also more time. So you can check a little more about inside our course. In this method, and I have one here. Okay, when we activate one of these guys here, and we go to solve, before the calculation, we may need to define the natural oscillation forms. So on the solve tab in the use frequency, where it is, solve. 1 second, solve. Okay, automatic. We can have these. Okay, spectrum of natural frequencies. So we can define and we can study the natural frequencies. We can activate these natural modes in the dynamic study. And we can control a lot of things. In the next lessons, we will see a little more about all these options. The second method, the transitional process, which, as I've shown, we have it here, the transitional process. The solution of the equations, it is found using numerical integration in time. So we have a full equation system solved in each time step that it is defined. This type of study may be recommended for short time dynamic process. The solution, it is exact, but it requires an increased computational resources and time. So because as you can already understood, the size of the equations, it is different. More that we can talk about these guys. So inside the parameters, we also can define time step. So the time that we study this process and the increment for this process. We have a couple of equations also to solve and to understand about the time integration method. Again, I will not bother you here with these topics. You can read a little about on the other side. We can assign also initial conditions in this area here, so we can apply displacements for static analysis. We can apply results of dynamic results. So we have a lot of options around here. We can have also enter some parameters regarding damping. The Rayleigh damping is accepted in the system. So we can define a couple of parameters in this method around this area. And we can also have in account something that is the thermal effects accounting that I think I don't have in this one here. Okay, I don't have on the so I should open the transitional. And now I should have, okay, here it is, the thermal effects, which as also we've seen previously for other types of studies, this tab allows to activate the dependence of the material properties from temperature mode. So we have a couple of parameters. They are basically the same seen in other types of studies. So we will see some examples, and we will see also about each of these individual parameters. So as first lesson for these dynamic studies, I think we've covered basically the major important points. If any additional help is needed, so let us know, send us a contact, and we will give you all the necessary support.